Greetings again, everyone. This week we are going to be looking at worksheet 8. Worksheet 8 is also based on graphs and basically the applications of simultaneous solving. The first part of simultaneous solving is a repetition of your last year's work. If you remember, last year we did simultaneous solving between two linear expressions. At the end of this lesson, students should be able to solve equations simultaneously to find the value of the unknown variables which satisfy both equations. Note, simultaneously means to solve for variables at the same time. Okay. Last year, we used three methods of simultaneous solving. If you remember them, elimination method, substitution method, and the last one was graphical method. Graphical method is quite a lengthy method, so it is not recommended. Well, you can always use that if you feel like that is an easier one for you. Elimination and substitution methods are the two methods which I will recommend for you to use. Now, this year, elimination method is only restricted for two linear equations. Linear equation simultaneous solving is quite rare this year. So the only option left for you to use is a substitution method. Linear equations, that is the only case where you are going to use the elimination method. So this worksheet focuses on linear equations only. Let's have a look at how to solve example 1. Okay, example 1 says 4x minus 3y is equals to 3 and 10x plus 3y is equals to 4. Now this question also serves as a recap activity from your last year's work. When we are solving this, first of all, I need to ensure that the coefficients of one of the variables has to be the same number, either for x or for y. And if they are not the same numbers, we will need to multiply the whole equation by a particular number so that the coefficients of one of the variable is same. Now this one, I can see y coefficient is 3 and here it is a 3 again. While this is a negative, this is a positive. We are thinking of eliminating negative 3 and a positive 3. How can we operate them to get a 0? Negative 3 plus 3. Negative 3 plus 3 is 0. So I am going to add the two equations. While we are adding, we are going to add all the corresponding components. 4x plus 10x, 14x. Negative and positive, they will cancel upon addition. 3 plus 4 is 7. And then we are left with only one variable. So divide by 14 both sides. Divide by 14. Cancel. X is equals to 7 divided by 14 is half or 0.5. So once we have found one of the variables, we can find the next variable using substitution. Okay. So I am going to substitute the value of x in place of x in any of the two equations, original equations. Let's use the first one. 4x minus 3y equals 3. X is half, so 4 into half minus 3y equals 3. Now in place of half, you can also use the decimal value of it. Decimal form, it is 0.5. 4 times half is 2. 2 minus 3y equals 3. Take 2 the other side, minus 2, minus 2. Cancel. Negative 3y is equals to 1. And then we divide by negative 3 both sides. Cancel. Y is equals to negative 1/3. So our answer here, keep in mind, answer has to be written in coordinate form all the time. Half, comma, negative 1/3. That's done with our example 1. Let's move on to example 2 of this question, of this worksheet. This one is a word problem. Word problems are more common for simultaneous solving linear equations in year 12 level. So let's focus more on this kind of equation. It says a total of 925 tickets were sold for 5,925. If adults tickets cost 750 and children's tickets cost $3. How many tickets of each kind were sold? Now there is two kinds of tickets. So first of all, let's give them a denotation. Adults is X. Children is Y. So that's my denotation. The total number of tickets sold is 925. So my first equation, X plus Y equals 925. That means there were X number of adults and Y number of children, while the total number was 925. The total income was 595, and this income was generated with the cost of adult tickets 750. So if there is X number of adults, per ticket is 750. The total number of adult ticket prices will be 7.50x. $7.50 times the number of adults. That gives me the total income generated by the adults only. Similarly, for the children, plus 3 times y equals 5925. Okay. Now, this is my two linear equations. Keep in mind, linear equations are those equations whereby the powers of x and y both are 1. If the power is not 1 for either of the variables, it is not a linear equation. Now I need to bring the coefficients of one of the variables to the same value. The y is a bad option, so I can multiply this one by 3. 3.00 is still a 3. So I'm just using a 3 here. So let's multiply that. 3 times x is 3x, plus 3 times y is 3y. 3 times 925 is 2775. Now I can subtract the two equations. 7.5 minus 3. 7.5 minus 3 is 4.5x. 3y minus 3y cancels. And then the equal sign, 5925 minus 2775. 3150. I've got only one variable. Divide by 4.5. Divide by 4.5. Cancel. X equals. Divide the two. You should get 700. So 700 adults tickets were sold. X is adults. Now we need to also find the number of children. We can use the first equation. X plus y equals 925. X is 700. 700 plus y equals 925. Minus 700 both sides cancels. Y is equals to 225. Now keep in mind, we cannot leave our answer in the form of x and y because the question doesn't have an x and y anywhere. That is our only notion. So finally we need to write our answers. Number of adults 700 and children 225. This becomes our final solution. If you leave your answers to x and y, you will get full marks, but that is inappropriate mathematics. We always need to write our answers in the appropriate form. Well, that brings us to the end of this video. Thank you everyone. I will see you next time.